good. Let's go.
Hi, my name is Leon.
My name is Robbie.
My name is Owen.
And I'm Ricardo Cruz.
And this is our presentation of the Annex 1 laws. Now, before we begin, let us introduce you about the Annex 1 laws. The Annex 1 laws is a directed energy laser weapon system, but because of this, the government has classified some of the information. So the information we are able to give you is not the most reliable, but the most accurate.
So to make sure that this information is as accurate as possible and you trust it, we're going to go over our roles in the group. I'm Owen Priest, and again, I'm the CAD designer and builder.
I am Robbie Osborne, and I am the project manager.
I'm Leo Steves, and I'm the researcher.
I'm Ricardo Cruz, and I'm the recorder.
What is it? Well, the Annex 1 laws is a laser weapon system which its main purpose is to take down small drones and small boats. Who uses it? Right now, the USS Ponce's Navy crew, the Proud Lions, currently use it. Where is it? Before we begin with this, let us introduce you to the USS Ponce. The USS Ponce is a Navy cruise ship which was originally going to be traded off to Argentina, but the UK had a problem with it, so it had to be decommissioned. But the crew and the captain had a problem with this, so instead, the USS Ponce had a better role, which brings us to the excellent laws. Right now, the USS Ponce is located somewhere near the Persian Gulf, but its current location is classified.
And now that we know the location about it, we can go into how the actual modern marvel works. And to understand that, we have to understand the base concept, which is the laser diode. I've prepared a clip from a video, as you can see here, and we'll just watch that now. It's a short 1-minute clip so that we can learn about the actual laser diode.
Common components of all lasers consist of, first, active medium, which can be a gas such as carbon dioxide laser, or krypton fluoride, for instance, in an X-ray laser, which is used to generate high-power UV pulses. The solid-state laser, on the other hand, has a crystal made of ruby, neodymium-doped yttrium aluminum garlet, or YAG, as we call it, or neodymium-doped yttrium lithium fluoride, just to name a few. The gain medium can even be a liquid, although dye lasers are not.
Alright, until it starts working, you can read the subtitles, as you can see here. Do you guys want us to restart it?
Yeah.
Alright.
The common components of all lasers consist of, first, an active medium, which can be a gas such as in a carbon dioxide laser, or krypton fluoride, for instance, in an excimer laser, which is used to generate high-power UV pulses. A solid-state laser, on the other hand, has a crystal made of ruby, neodymium-doped yttrium aluminum garlet, or YAG, as we call it, or neodymium-doped yttrium lithium fluoride, just to name a few. The gain medium can even be a liquid, although dye lasers are not used in micromanufacturing, and there are several reasons for that. The pumping source, or energy input, can be electrical, such as an HV discharge in an excimer laser, or it can be optical, using laser diodes to pump, for instance, a YAG or fiber lasers. And lastly, all lasers need an optical feedback. And this consists of a mirror or a high reflector and a partially reflective mirror, and we'll talk much more about that later.
Alright, now that we know a little bit about lasers themselves, we can actually analyze, based on the videos and research that we did, what type of laser our model is. We identified our laser as a ruby solid-state continuous wave. And that just means that continuous wave, it's like a laser pointer. When you push the button, it'll go until it runs out of battery, and it doesn't pulse or flash. And ruby medium just means that since ruby is a solid, it's a solid state, and the photons passing through and then refracting out are using the ruby as a medium to shoot out. And now that we know that, we can move on to the design challenges because we know how it works. So, of course, there's going to be a problem along the way. There always is. And the designers got pretty creative with how they built this. So, lasers are inherently weak. So the way that they fix this is using a YAG or YELF system that they mentioned in the video. And so it starts off with having the laser light go through the optical cable, as you can see in the top of the image to your left. And it goes through an optical isolator, which is basically just a filter to ensure the only light going through is laser light. And then it goes through filter, which again, it just takes out the light that's being pumped by the laser pump. The purpose for the laser pump is to excite more photons in the optical cables to ramp up the amount of energy that the laser has. And after it gets pumped by the laser pump, it goes back through the optical isolator and out the other side as a newly formed super powerful wavelength. Now I'm going to go over just the beginning of how the system gets its power, as in the output system. And so the output system gets its power from 6 Ruby solid-state diodes. And those can be represented by the 10 in the picture to your left. And right here, we just have a simple kind of floodlight being put into clear optical cable, and you can even see the change in wavelength as it goes down. That's why you see different colors. And now moving on to that, now that we know, again, how the entire system works, we were able to make a couple designs. And so here you can see a couple pictures that we were able to find on different models. Now, there were a ton of different designs, so we tried to kind of mix match all of them to create the most accurate model, because every time that they would update it, they would change it, as you can see in the pictures right here. And so we started off with a paper model, which we had to remake the paper model because we left it in a closet with a bunch of high schoolers, and this is all that's really left. So we made this cardboard model right here. Now this was just to get the general idea of how it was shaped and how it was looked for the SolidWorks later. And now here you can see a couple pictures of just, I added backgrounds and a couple different views. And it took me quite a bit of time to build the SolidWorks, and then I took it over to my 3D printer. And I redesigned it on Autodesk Inventor, printed it out, and as you can see, it doesn't look very much like the actual model. So for the final design, I spray painted the parts after experimenting with the circuit a little bit. And so right here you can see the parts waiting to dry. Here you go. And here you can see it all assembled, which that's the thing that you see right there today. And right there it's just another view in the light. And right here you can see the laser diode mounted inside. Now I'll have a live demonstration of kind of how the laser works. This took a long time to kind of make because nobody had made something like it. So as you can see, I added a pivot in the design, and you can actually see that when I turn it on, you can actually see the laser. It's kind of very faint. I don't know if we can turn off the lights, but it is kind of seeable in this light. You can sort of see it. And now, since this is just one laser diode, we don't really need a control center like you'll see later in the presentation. So I actually just rigged up an on and off light, and this is just like a TV circuit. When you turn it off, the red light turns on. So if you guys want to come up and take a look afterwards, you can. So as you can see, it's off, there's no light coming out, and then the white light indicates that it's on, and that's all we really need for the simple model that we have built. All right, so I'll pass it around. Try to be gentle. It's pretty durable because it is plastic. Don't touch the lens on the inside if you have one.
We're also going to pass the cardboard model around as well.
I doubt you guys want to see the paper model. So.
Okay, so for the cost of XM1 Law's prototype, it cost $45 million for the research, development, and the creation of the XM1 Laws. But it was worth it because of the $1.50 per shot of the XM1 laser, compared to the $400,000 missile, which does exactly the same as the laser. It's said to be more accurate than a gun or a bullet. And here's a demonstration of the laser working.
This is meant to simulate kind of a missile on an enemy ship. It's targeting the missile right now, so it's not just an explosive out in the open, which that's what we originally thought, and then we figured out that it's just meant to represent a missile.
This is it taking down an UAV, unmanned aerial vehicle.
you can see, the newer model only takes about 2 seconds to actually take down one of these drones, and that includes blinding its sensors and taking it out of the sky into the water or wherever it's meant.
So for the energy of the XM1 loss, it uses 30 kilowatts for one shot of the laser, which is about, if you use 30 microwaves for 1 hour. And for the upgrade set by Donald Clegg, Director of Business Development and for DRS Power Control Systems, he says that he wants to combine the service from ships and the XM1 loss to be able to use 3 times as much power as it did when it was a prototype. It will be consuming 450 kilowatts, but will be throwing out 150, which is a lot. And it will be, from what it's consuming, it will use 1/3 of the energy.
Okay, so now that you know how much it costs, we're going to see why is the XM1 loss a modern marvel. Well, it is a modern marvel because it is an amazing feat of science. It's really hard to make a laser. Is it hard to make a laser?
Yes, very much so.
It is very hard to make a laser. And it is also, as you've known, very cost efficient and very, very accurate. So what problem did it solve? Well, the Navy used to use missiles, very high cost missiles, to try and take down small boats and flying aircraft. And it would add a high chance of missing, and it would probably, if you're trying to just stop the boat, it would just blow the entire thing up instead of just stopping it so you can stall it and tell it to retreat or something. Okay, and now, should the XM1 law have been built? We think that it should have been built because it is a step forward in military weaponry, and it is very cool. It's laser. Wait, come on, it's awesome. Okay, thank you for watching our presentation. Any questions?
So you mentioned that like it'll keep running until it runs out. So when will it run out? Like how long can it keep running for?
So like we said, when it's a very high-powered shot, it'll take up about 1/3 of the ship's energy. So if you're running it on full power, which is ridiculously strong, around, I think we estimated about 450. So 150 is like a low-power shot. So when the battery runs out, if you were to do high-powered shots, that's about only 3 of those, and then the boat is completely out of energy reserves for the laser itself. So when I say until it runs out, it's not going to fire and then you can't stop it. You do have switches to take it off, and of course it only takes about 2 seconds, like I said, on a low-power shot to take something down.
And my second thing is that like a beautiful presentation, but like I would like to see like your other teammates also get a word in. Like you guys talk, but like I think it'd look better if like you like spread it out between all of you guys instead of like, you know, like just you talking and like maybe 2 other people. Yeah.
Questions? Yeah.
Is there any environmental impacts?
So we didn't talk about that very much because we can't get any information on this.
Yeah.
We had to base a lot of this on the little scraps and bits that we got from news interviews and stuff. So the only environmental impact would be maybe spilling oil for the ships into the ocean if you did take down a ship, which in current use, it wouldn't be doing that, or so we think so, but then again, we can't get any information.
What are the current challenges in operating it as far as, say, targeting things and the accuracy, being able to track and lock on and target? What prevents this implementation?
As for your question, we couldn't get much on it because of government reasons.
What we were able to get, though, is we actually saw it, and from an interview with the guy who pilots it, it looks like an Xbox controller, because the computer does a lot of it for the laser's purpose, so it can auto-track and stuff, so you don't have to be manually doing it. So all you have to do is set it on a target with the controller, and then monitor when it fires, and that's about it. The computing does the rest of it.
So basically, what you're saying is that basically it's glorified ABOT in a sense.
Yes.
Okay.
Yes.
Yeah, I like to try to focus. I mean, lasers are great, technology is great, but I like to focus on real world, real life stuff. Leo is sick as a dog today. I saw him this morning. He looked like he was going to keel over and pass out. He's still up there. He's fighting through it. A lot of you people didn't even present, which is sad. He is up there fighting through this, and you know, that's what separates people. That's what separates you guys. It's not society at times, it's you. Are you gonna stand up and fight, or are you gonna sit back and watch? Okay, so I got a lot of respect for that. It's cough, Leo, cough it up, baby. Yeah, a lot of respect.
And Leo.
In like what are like okay, so you said this is all classified, and you obviously don't know where the exact location is, but when and where would we generally be using this? Like what kind of applications as of right now are they using, or if you know if they're using it for?
I get the question. So actually what they were using it, or planning to use it for, is stuff like the small swarm boats. So you've got like 2 manned boats, and you just have like a ton of them over a large area, and that could be used to very quickly take out all of them without necessarily harming any people.
Okay.
It's in testing stages right now, so we don't really know what's going on.
All right, guys, thank you very, very much. Who you got next, man? Who's next?
Next, we have Eduardo Hall.